everyone. So in this class we will see our next concept, that is solution system of linear equation. If you know the system of linear equation, okay, if that system of linear equation is given, how to find the solution of that system of linear equation, okay. System of linear equation is nothing but what? a1x plus b1y plus c1z plus d1w is equal to k1. This is the first equation. Similarly, if I am having a2x plus b2y plus c2z plus d2w is equal to k2. Similarly, if I am having third one is a3x plus b3y plus c3z plus d3w is equal to k3. And last one is a4x plus b4y plus c4z plus d4w is equal to k4. Suppose if this is the solution of the system which is given, then how to find the solution is, we want the value of x, y, z and w here. Okay. So what is the method? This method is called matrix method, and you studied in PUC if system. I think you studied of order 2 or order 3 only. Okay. But here we will see of order 3 also, order 4 also. Then we have to consider, by using matrix method, we have to consider the matrix. Then we have to consider the constant matrix. Okay. Then how to find that? Okay. You all studied this in PUC. Only here, in that you use the matrix method by finding the minor of matrix. Okay. Cofactor and minor. But here, directly we will use the matrix method. So by using elementary transformation. Okay. So what is the first step? We have to consider the matrix A using the coefficient of x, y, z and w. So using first equation, write down the first row here. So here what is the coefficient of x? A1. You will get here b1. Here you will get c1, d1. Coefficient of x, y, z, w, because x, y, z, w are the variables here. And a1, b1, c1, d1. Similarly, this a4, b4 up to d4, they are the constant. Okay. So write down the constant term. So a2, b2, c2, d2, a3, b3, c3 and d3. And next one is a4, b4, c4, d. So this is your matrix A. Okay. Consider the coefficient of x, y, z, that will give the matrix A. Next we have to write the matrix B. So here the matrix B is nothing but these constant terms. Okay. So here we are having first is A1, and write down it is in the form of column. Don't write it is in the form of row, because using first equation we have written first row. So obviously this becomes your first row. This becomes your second row. Okay. So K2, K3 and K4. Okay. Write down the matrix B also. And write down the matrix capital X is nothing but the variables x, y, z, w. Okay. This is the matrix X which contains the variables. Then we have to consider the equation Ax is equal to B. We have to consider the equation Ax is equal to B. Okay. Now go on, apply the elementary transformation of this and this matrix. Here x is variables, we have to keep this matrix as it is. Go on, apply the elementary only row transformation. Don't apply column transformation. Only here we have to apply the row transformation. Okay. So go on, apply the row transformation of these two matrices till, okay, first we want this first element should be equal to 1. In the first row and first column, we want the first element is equal to 1. Then try to make below the diagonal, these two diagonal elements are 0. Okay. Then you will get this equation. Then you will get here some elements. Okay. Suppose if this is of order 3, you will get some elements. Then in the here you will get one element. Okay, we want, don't make all these three elements are 0. No, try to make at least one element here. Okay, remaining two are 0. If this is 0, then here you want one element. Okay. Now suppose if you are after you reducing this into this form, then again and we have to operate the same elementary transformation of this matrix B also. Okay. Then after this, again write down this matrix into the equation form. Again in the equation form. Okay. Using this you will get one equation. Using this one element obviously 0, you will get two variable equation. Here you will get three variable equation. Then go on solve this third equation. Whatever you are possible, solve that equation. Now using, if you are solving the equation 3, you will get either the value of y or either the value of z. Okay. Then go on substitute back. Okay. Then substitute that value of y and z, either it is y or z, in this equation, second equation. You will get another remaining variable value. Then using that two value, we can find the third remaining value. Okay. Using this first equation, you will get the value of x, y, z if it is of order 3. If it is of order 4, suppose if it is of order 4, then try to make this below. Again, procedure is same up to this. Try to make this is 1 and this is 0. Then try to make this 2 are 0. Then try to make this is equal to 0 or this is equal to 0. Then here also we want the matrix should contain at least one row with single elements. Then only we can find the values of x, y, z and w. Okay. So this is the method to find the solution of system of linear equation. Okay. So we will see the examples depend on this. Solve the system of equation. Solve. We have a question here. Solve the system of equation by matrix method. Solve the system of equation by matrix method. By matrix method. Solve the system of equation by matrix method, and here the system of equation is given by x plus 2y plus 3z is equal to 6, 2x plus 5 minus z is equal to minus 3, and 3x minus 5 plus 2z is equal to 11. Okay. Now apply this step. Using this three system of equation, we can write the matrix. If you are having 3 equation, you will get matrix of order 3. If you are having 4 equation, you will get the matrix of order 4. But here we are having it is of 3 equation, then we will get it in matrix of order 3 only. Okay. So write down now using first equation. What is the first we will get? Here coefficient of x is 1. Here it is 2. Here it is 3. Here it is 2, 1, minus 1. 3, minus 1, 2. This is nothing but matrix A. Then write down the matrix B here. What is the matrix B? 6, 3, 11. Constant. Okay. And what will be the matrix X is nothing but, here what are the variables? Unknowns, that is x, y, z. Okay. Now consider Ax is equal to B. Consider Ax is equal to B. Now what is the matrix A we are having? Matrix A is 1, 2, 3, 2, 1, minus 1, 3, minus 1, 2 into the matrix X, that is x, y, z is equal to the matrix B, that is 6, 3, 11. 6, 3, 11. Okay. Now go on, apply the elementary transformation of the matrix A and matrix B. Okay. So we want first element should be equal to 1. Already here we are having sorry, first element is 1. Now try to make these two elements are equal to 0. Then what is the procedure? R2 changes to R2 minus 2R1. Okay, because 2 minus 2 will get 0. Next, R3 changes to R3 minus 3R. Okay, then try to make these elements are 0. First row as it is. R2 minus 2R1, similarly it is 0. Next, for this R2 is 1, minus 2 into R1 is 2. So 1 minus 2 into 2 is 4, you will get here it is minus 3. Next, minus 1 minus 2 into corresponding R1 is 3. So minus 1 minus 6, you will get here it is minus 7. That is the first row. Sorry, second row. Next, apply the third. 3 minus 3, you will get this is 0. Next, we are having here minus 1. Minus 3 into R1 is 2. So, minus 1 minus 6, that is nothing but minus 7. And next, you will get 2 minus 3 into R1 is 3. So, 2 minus 9. That is, you will get here it is minus 7. Is it? 1, 2, 3, minus 3, minus 7. Minus 7, minus 7. Correct. Keep this matrix as it is. X, Y, Z as it is. Now same apply the elementary transformation of this matrix also. So what first row as it is. What we have? Second row is R2 minus 2 R1. So 3 minus 2 into R1 is 6. So 3 minus 2 into 6 is 12. So you will get 3 minus 12 is nothing but 9. Minus 9. Minus 9. Okay. Next for the third row, what is the transformation? R3 minus 3 R1. So R3 is 11 minus 3 into R1 is 6. So you will get 3 into 6 is 18 and you will get 11 minus 18 is nothing but minus 7. Minus 7. Okay. So this is the matrix after applying the elementary transformation. Wait a minute, whether I have made the mistake. 6, 3, 8. Is it? The matrix is 6. Sorry, this is nothing but minus 3. Sorry. So you will get here it is minus 3. So this is minus 3. Okay, sorry. So minus 3 minus 2 into 6. So minus 3 minus 12. So you will get it is minus 15. Minus 15. Okay. Now what we want? Either we want this element is 0 or this element is 0. Okay. Now here, if you see here we are having minus 3 and we are having minus 7, you will get difficult to apply the transformation. Now if you see these two elements, here we are having minus 7, here we are having minus 7. If you take the minus sign, if you subtract these two, you will get here it is 0. So make this element is 0. So what is the transformation? R3 changes to R3 minus R2. Because R3 is minus 7 minus R2. So R2 is minus 7. So minus into minus you will get plus 7. So minus 7 plus 7 you will get it is 0. Okay. So apply this transformation. So you will get first row as it is. Second row also as it is. Third row 0. R3 minus R2. So minus 7 minus of minus plus 3. So here you will get it is minus 4. And this value is 0. Next x, y, z. This is equal to first row as it is, second row as it is. Apply the third R3 minus R2. So minus 7 minus of minus plus 15. Is it? Yes, minus 7 plus 15. So you will get the answer is plus 8. Plus 8. Okay. Now see, now we are having here we are having this matrix contains one row which are having the single elements. Okay. So how we write the equation here? First equation is nothing but, see, we have to multiply this, right? So 1 into x is x, plus 2 into y is 2y, plus 3 into z is 3z. So you will get first equation is x plus 2y plus 3z. Okay, x plus 2y plus 3z is equal the corresponding constant, that is 6. Next, here we are having 0, 0 into x is 0. So you will get minus 3 into y minus 7 into z is equal to minus 50. Okay, call this as 1, call this as equation number 2, and we are having equation 3 is, here we are having 0, here we are having minus 4, so we have to multiply with y. So minus 4y is equal to 8. Is equal to 8. Call this as equation number 3. Now if you see the equation 3, we can find the value of y using equation 3 here, right? So what is the value of y? You will get 8 divided by minus 4, that is minus 2. Okay, substitute that minus 2 value of y value in equation 2. So equation 2 implies minus 3 into y is minus 2 minus 7z is equal to minus 50. Okay, so the solution is what? The value of x is equal to 1, the value of y is equal to -2, and the value of z is equal to 3. Okay, so this is the values of x, y, z. This is the method to find the value of x, y, z. Okay, so this is one problem. Similarly, we are having second one. Again, solve the system of equation. Here, system of equation is given by, this is the important problem for farmers. X plus y plus z is equal to 2. Next, we are having 2x minus y plus 3z is equal to 8. And next, we are having 3x plus 2y minus z is equal to 3. Okay, again use the same procedure. Write out the matrix A, matrix B, and matrix X. So A is equal to what we will get? 1, 1, 1. B is equal to 2 minus 1, 3. See, the third row is 3, 2 minus 1. Right? So matrix B. What is the matrix B? 2, 8, 3. And the matrix X is nothing but X, Y, Z. Okay? Variables. So we have to consider Ax is equal to B. Okay? What is the matrix A? 1, 1, 1, 2 minus 1, 3, 3, 2 minus 1 into the matrix X is X, Y, Z. This is equal to the matrix B is 2, 8, 3. 2, 8, 3. Okay? Now already here we are having first element is 0. So we will make these two elements are equal to 0. So how we will apply? R1 changes to R1 minus, R2 changes to R2 minus 2 R1, R3 changes to R3 minus 3 R1. Okay, then you will get these two elements are 0. So apply the transformation now. We are having R2 changes to R2 minus 2 R1 and R3 changes to R3 minus 3 R1. Okay, that is the one matrix. So we will get the corresponding matrices. First row as it is 0, 0. R2 minus 2 R1, right? So here we are having -1. -2 into corresponding R1 is 1. So -1, -2, that is -3. Next here we are having 3. So 3 minus 2 into corresponding R1 is 1. 3 minus 2, you will get it is +1. Okay. Now similarly apply for third row. R3 minus 3 R1. So 2 minus 3 into 1 is 3. So 2 minus 3, you will get it is -1. Here we are having -1, -3 into R1. So -3, that is nothing but -4. So this is the matrix. Write down X, Y, Z matrix as it is. This is equal to, again apply for this matrix also. So first row as it is. What? R2. R2 is 8 minus 2 into R1. R1 is 2. So 8 minus 4, you will get here it is 4. R3 minus 3 R1. R3 is here 3. 3 minus 3 into 2. So 3 minus, you will get 6. So you will get 3 minus 6 is -3. Okay, so this is the matrix. 2, 4 minus 3. Yes. Now try to make either this element is 0 or this element is 0. Okay. So if you see here, it is possible to make this element is 0 because here we are having 1, you will get easy. So apply R3 changes to R3 plus 4 R2. Is it? Because R3 is -4 plus 4 into 1 is +4, you will get it is 0. Okay. So what is the matrix then? 1, 1, 1, 0, -3, 1. R3 here you get 0 only because here we are having 0. R3 is -1 plus 4 into R2 is -3 here. So -1 minus 4 into 3 is 12. So here you get it is -13, right? Next, here we are having -4, so obviously it is nothing but 0 into X, Y, Z. This is equal to 2, 4. Apply the same transformation. R3 is -3 plus 4 into R2 is 4. So you will get -3 plus 4 into 4, that is 16. So you will get -3 plus 16 is nothing but plus 30. Plus 13 or -13. -13 plus 13. -3, 1, 2, 4. What we are having? R3 is -3 plus plus 16, that is plus 13 only. Okay, plus 13. Okay. Now write down this in the equation form. So x plus y plus z is equal to 2. Second we will get minus 3y plus z is equal to 4. And third we will get minus 13y is equal to 13. So from this, what is the value? Okay, call this as 1, this as 2, this as 3. Now from equation 3, what we will get? The value of y is nothing but 13 divided by minus 13, that is minus 1. Is it? The value of y is nothing but minus 1. Next, try to find the value of z using equation 2 here. So if you consider equation 2, what is the equation 2? Minus 3, what is the value of y we got? Minus 1. So minus 3 into minus 1 plus z is equal to 4. So minus 3 into minus 1 plus 3 plus z is equal to 4. So you will get z is equal to 4 minus 3. So z is equal to 1. Right? Next, using equation 1, find the value of x. So x plus y value is minus 1. So x minus 1, z value is plus 1 is equal to 2. Minus 1 plus 1 is 0. Directly you will get the value of x is equal to 2. So what is the solution we are having? X is equal to 2, y is equal to minus 1 and z is equal to plus 1. This is the value for x, y, z. Okay. So this is the method to find the solution of linear system of equation. Okay. So these are the two examples. We will solve the remaining examples in the next.